Okay, this is the homework for module 9. Now, um, so I'm going to talk about this generally, and you're going to see my answers because, again, for every homework, I'm always doing all of the homeworks. Obviously, I think it's a little improper to assign something and me not do it myself. Um, so I want to just briefly, I mean, you're going to see the answers here. It's not getting the right answer is not really the point, because when you do the exam, you're going to have to come up with the right answer, and you've got time, only so much time to complete it, so you don't want to be figuring it out at that point. So let me just talk generally about some of the theory or some of the processes for solving each of these, and then hopefully that'll kind of help you think about this. So for question number 1 in module 9, we're asked about food samples, food products, and determining whether it's safe or not. So again, H subscript 0, that's our null hypothesis. The alternative hypothesis, H subscript A, is that the food is not safe. We're never, in these kinds of tests, we're never proving something is true. All we really are doing is we're either rejecting the null hypothesis or not rejecting the null hypothesis, but we're never proving anything. So really what we have to think about here is, can we reject the null hypothesis, or can we not reject the null hypothesis? And there are two types of errors that can exist in any of these hypotheses. One could be that you reject the null hypothesis even if it's true. That would be called a type 1 error. Or in other words, we might think of that as a false positive. Another type of error, a type 2 error, would be one where we'd have kind of the false negative, which would be that we don't reject the null hypothesis even though it's false, which is exactly what's going on here. The sample suggests that the food is safe, but it's actually not safe. So the null hypothesis is not true, and we're actually saying that it is true. So it would be a type 2 error. So that's definitional. In this example here, I have a p-value. So let's just review a little bit about what a p-value is. So a p-value, what that is it's giving me a probability. It's giving me a probability for obtaining a sample that's basically more extreme than the other items I found. So what we're trying to do here is we're trying to basically find the area under a normal distribution curve. And what the p-value does is it tells us our probability of getting something even more extreme. So imagine that this is like the left tail or the right tail of a distribution. It'd be like saying you're going further to the left if it was a left tail, or further to the right if it was a right tail. So here I have a p-value that turns out to be 0.07118. Or in percentage terms, that would be 7.118%. At a 9% level of significance, what is the proper decision? In this case here, if the p-value is 0.07, but the level of confidence we want, or the level of significance there, they're opposite ways of thinking of the same thing, level of significance and level of confidence. If the level of significance is 9%, but the p-value for the hypothesis is 0.07%. In this case, I would need to reject the null hypothesis because I don't have 9% confidence that the null hypothesis should not be rejected. I have to reject it because I actually have less of a probability than my 9% here. Now for number 3, we got riding the school bus. I grew up on the mainland and I had to ride the bus to school. Mine was about 30 minutes, so I guess that's about true. So we're running a test here. We want to see how long it takes kids, how long they're riding the school bus. And we're asked here, what would a type 2 error mean? Remember, again, that the type 2 error, if we think about that, again, that's the false negative. So that would be that the data would say that we aren't higher than 30 minutes, when in fact it is higher than 30 minutes. So that's the only, it's a definitional thing of what is a type 2 error. Okay, now we get into some of the cooler stuff here. So for number 4, what we're looking at here are probability values, and we need to test it at different significance levels. So if we're looking at all night students and we're looking at their mean GPA, that it's different than 3.5. So different would mean both left tail and right tail, or not equal. And at the 0.1% significance level, the null and alternative hypothesis would be written with the mu's, not the proportions. It's written with the mu's because we actually have the population of night students where it's equal to 3.5%. And what I'm testing for is that it's different than 3.5, meaning not equal. So left tail, right tail. Because it's both sides, that's why it's two-tailed. It would be right-tailed if it was greater than. It would be left-tailed if it was less than. But now we're saying it's actually both sides of it. Now, to calculate the p-value, what we need to do here is we need to calculate the z-score. And from the z-score, then we can get the p-value. So, sorry, I'm just, like I've said before for other, points here, you don't need to, do this by hand. There are calculators out there that will do this for you. The one you're going to use here, because you are given your standard deviation, is you're going to be using something like a z-score calculator, where you would type in your raw score. In this case, 3.46. Population mean, 3.5. Standard deviation, 0.04. Let's see what I got here. But I just want to make sure I calculate the right thing here. No, I didn't. I used the wrong calculator here. Sorry about that. And the way I would know that is because I didn't have to type in my sample size, which I would have needed. So I'm doing it from a sample. .04 and 70. And I want this at the 0.1 significance. So 0.1 significance would be 99% confidence, which gives me a z-score of 2.58. Which is going to give me my p-value, which is essentially 0. And so because of that, I can reject my null hypothesis. So I did 2 steps there. I calculated my z statistic from a sample, and then I used my z statistic to get my p-value. The z's, remember, if you remember from the previous module, z is equal to 0 at the mean. And then the z's go negative when you go to the left of the mean, and they are positive to the right of the mean. I'm using that z statistic to find my p-value. So I used one calculator to find my z, then I found my p. Yeah, and I think for these as well, you can watch the video as well. I don't watch them, but I'm sure they're helpful. Otherwise, why would they give them to you? This is somewhat similar here. I've got a textbook. I've got a textbook where the bookstore says it cost $81.33. Others say it's not. So again, these would be populations, not samples, sample proportions. These would be the population. So it's either that it's equal to 81.33, or others saying no, it's not. They're not saying it's cheaper or it's more expensive. They're just saying it's not. And that's why here it says the average price of all textbooks, not proportion, not sample, but all books in the store. And it's not the tails, which is what's right here, all textbooks. And so now what I need to do is somewhat similar here. I need to find the z statistic, then I need to calculate the p-value. I have a confidence interval here of 95%. The point estimate, that's just the mean, which is right here. So that's what the point estimate is. I have a 95% confidence interval. And you can get that right here. So here I just used a confidence interval calculator. 95%, 170 sample size, put in the sample mean, put in my standard deviation, put in my confidence level. Calculated that, and I've got 87.73 plus or minus 3.608. So then I did minus 3.608 plus 36.08. Now I know what my 95% confidence interval is. And if I go back up to here and people are saying 81.33, it's not even in my 95% confidence interval, which is why I then reject the null hypothesis. Here, I'm testing it with a proportion of people that owns cats. Proportion, not the sample, not the population mean. It's two-tailed because I'm saying it's different than 90%. Not less than, not greater than. We're just saying it's different. I need to find the p-value. We've already kind of gone over how you find p-values. And we're doing that with a sample here. Now, the way that you're going to get this proportion where you're going to test it is you need to do the one proportion z statistic, which is what I did right here. I did a z-test to compare single proportions to the population estimate. single proportion to the population estimate, single proportion to the population estimate. And I tested that. 500 people, 83%. This is just the results. I could go back here and whatnot, but population proportion was 90%, significance level 1, 2. What I like about this is that the answers it gives you is you'd have to be, I don't know, really sleepy, really drunk. I don't know, something to get this wrong, because it's already told me I can just reject the null hypothesis, which is what I did. So that, again, would be z-test to compare single proportion to the population estimate. Now, in number 7, what I'm looking at here is I need to find my single sample confidence intervals, because I have a single sample here where I have n as 18, that's my sample size, mean of 55.6, standard deviation of 9.4, significance level would be the 99.5% confidence or significance of 0.005, and then my population. So I need to calculate the p-value from that. So I need the single sample confidence interval. And again, there are calculators out there, which is what I just used right here. You're basically doing a one sample t-test here. And you would type this information. Single sample confidence interval, but you're doing this with a one sample t-test. So, sorry, the calculator you want is the one sample t-test. You can see here that what I did is I typed in I'll just enter this in again here. N is 18. And so what it's doing here with the one sample t-test is determining whether what my tails are here and whether it's statistically significant or not. By typing in that data for the one sample t-test, what I see here is that there's a 95% confidence interval for that mean, but that my two-tailed p-value is 0.0052, but it's two-tailed. I actually only want one tail. So because I only want one tail, I'm actually going to take half of that 0.0052, which is why I put in 0.0026. And I'm only looking at one tail, the left tail, which is why I said less than. And because of that, p-value, which is less than my significance level, that's why I rejected my null hypothesis. And the way you would read that would be that basically the sample data doesn't support the claim that it's less than 62.7. In fact, we should reject it because the p-value suggests that less than 0.005 that is true. Here in question 8, The challenge here is that we actually don't know what the standard deviation is. So because we don't know that here, what we're going to be looking for here is the confidence interval of a proportion. So we start off with just a simple way of saying that for my proportion 8 out of 10, it's either 8 out of 10 or it's not 8 out of 10. That's my proportion, not my population mean. But the proportion is 0.8, so it's just another way of reading the null hypothesis, H subscript 0. And so now, without a standard deviation, I need to calculate this confidence interval for the proportion. Sorry, I had it here. So if out of 160 people, 111 say they prefer it, well, what I just did here for this number is I just put in 111 divided by 160 because that was what the mean proportion was for the sample. And now I want the 99% confidence interval, which is what I put in here, my confidence interval calculator. Not putting in a standard deviation, I found that my 99% I found that my 87 point, sorry, that's my other one here. I should organize this better. My confidence interval for the proportion was 160, that I actually found 111 for the 99% confidence level, that my lower bound was 59%, my upper bound was 78%. So given that, it's not likely that at the 99% level that I'm within my, that I'm around 80%, which is why I rejected. So 0.592, 0.784 came from here. So again, the whole point, I don't, sorry, let me just show you the last one here and then I'll conclude here. Null and alternative hypothesis just is just the left tail because that the left tail is just less than. If you rejected it, then you would really be saying that it's decreasing over time. I don't want you to think that you should be fast and loose with the homework and that you're either getting shortchanged in your ability to understand the statistics or that you're somehow cheating the system. But again, the whole point of this is that you know which test to use and when, and that's what's going to help you on the homework. So really, I'm just treating these videos, even though you're seeing what my answers are when I did it, I'm going over for you what test you use. And you'll then kind of write your notes around that so that you use the homework as a way to help train you how to do the exam well. And then when I get the lecture made, I'll talk a little bit more about what those tests all are.